Beneath the dappled surface of a shallow tropical reef, where sunlight breaks into ripples that flicker across the coral floor, a predator lurks in plain sight. Or rather, it was lurking until it disappeared. Not behind a rock, not into a cave, but into the very fabric of its surroundings. Where once there was flesh and eye and tentacle, there is now nothing but stone and seaweed, indistinguishable from the reef it rests upon. This is no trick of the eye, no illusion born from distance or murky water. The octopus has truly vanished, and it did so without a sound. The common reef octopus, Octopus cyanea, is among the most gifted vanishing artists in the natural world. Its skin is a living canvas, constantly shifting in color, brightness, and texture. At the center of this biological magic is a network of chromatophores, pigment-filled cells just below the skin's surface that expand and contract with astonishing speed. Each cell is like a microscopic ink sac, controlled by fine-tuned muscle fibers and neural connections that respond instantly to the animal's surroundings. When the octopus hovers near golden coral, its skin flushes with mottled browns and ochres. When it glides over pale sand, the pigments retreat and the skin lightens to a near white haze. Some transitions take less than 0.2 of a second, yet color alone is only part of the illusion. Texture is the other half. Using papillae, small, muscular structures that raise and lower skin like a topographical map, the octopus can roughen its surface into barnacle-like bumps or smooth it flat like wet stone. Combined, these abilities allow the animal to match not only the hue of its surroundings, but the structure, turning itself into a piece of coral rubble, a coil of algae, or a shard of rock. To the untrained eye, even to most predators, it vanishes entirely. But this mastery of disguise is not static. It moves, flexes, adapts in real time. Watch closely as a reef octopus shifts along the ocean floor, its tentacles flowing like ink down the slope of a coral outcrop. With each inch, its camouflage updates to the new terrain. Spots darken where shadow falls, edges blur against moving sand, textures lift and collapse like breath. It doesn't hide in the reef, it becomes it. This evolutionary genius was not shaped for beauty or artistry. It was built for survival. With no shell, no spines, and no venom of its own, the octopus is among the most vulnerable hunters of the reef. Everything hunts it: sharks, moray eels, groupers, even other octopuses. And yet it persists, not through confrontation, but by removing itself from the equation altogether. To hunt, it hides. To survive, it vanishes. And it's not merely reactive camouflage. Octopuses use their skills offensively. As they stalk crustaceans and fish, they slink undetected within arm's reach, their appearance so convincing that prey don't realize the danger until it's too late. A crab grazing near what looks like a patch of seaweed suddenly finds itself enveloped in a net of arms, suction cups locking down with hydraulic force, the beak striking from beneath like a hidden dagger. The attack is fast, efficient, silent. No struggle, no warning, just disappearance, then death. Among the most extraordinary of these hunters is the mimic octopus, Thormoctopus mimicus, found in the silty shallows of Indonesia. Unlike its reef-bound relatives, the mimic doesn't just vanish, it impersonates. It changes shape and movement to copy other sea creatures. A lionfish's flared spines, a flatfish's swimming pattern, even the banded posture of a venomous sea snake. These aren't random guesses. They are context-dependent performances. When threatened by damselfish, the mimic octopus imitates the damselfish's predators. When navigating sand flats, it adopts the guise of animals best suited to that terrain. This is not just camouflage. This is behavior masquerade, informed by the predator's own threat model. Its performance as protection, deception as survival. Even more remarkable is how all this is controlled by a nervous system, unlike any other in the animal kingdom. 2/3 of an octopus's neurons are not in its brain. They're in its arms. Each limb acts with semi-autonomy, exploring, tasting, and reacting with minimal input from the central brain. This decentralized intelligence allows the octopus to multitask on a level that borders on alien. One arm might be investigating a crevice while another is anchoring to a rock, and a third is gently flushing sand over the body to complete the disguise. It is a body governed by fluid coordination, capable of complex problem-solving without any vocalization, without any visual signaling, and with barely a ripple to betray its presence. Yet for all its talents, the octopus is short-lived. Most species live no longer than 2 years. Many die after mating or after a single reproductive cycle. The mother octopus starves herself while guarding her eggs, refusing food for weeks, her body breaking down as she fans her clutch with oxygenated water until her last breath. And yet, in that fleeting life, she will have outwitted predators, tricked prey, changed shape 1,000 times, and lived as both shadow and hunter. Her death is silent, unseen, like her life. To the casual diver or snorkeler, the reef may seem still, but hidden within that stillness, woven between coral fingers and inside cracks no wider than a coin, live the ocean's most accomplished phantoms. They are not the largest, not the fastest, not even the most fearsome, but they are unmatched in the art of not being seen. When they strike, it feels like the sea itself turned against you. And when they vanish, you're left staring at nothing and everything. In the open waters just beyond the coral shelf, where the reef gives way to a deepening blue and light begins to soften into haze, a shape glides silently forward. It's a squid, fast, sleek, and seemingly smooth-skinned at first glance. But as a shadow from above crosses the water, the squid flashes. Not with panic, but with purpose. Its skin ignites in a ripple of color, bronze to silver, then an electric shimmer of blue-green pulses along its flanks. Within moments, it vanishes into the visual noise of the sea. It hasn't moved far. But to the eye of a predator, it's as if the squid was never there. What the squid possesses isn't just camouflage. It's not passive concealment. It's active visual manipulation. A control of light and color so precise, so immediate, that the animal's skin becomes something more than a barrier. It becomes a sensor, a screen, and a tool of deception, all layered into one living surface. This remarkable ability is made possible by 3 classes of specialized cells layered beneath the squid's epidermis. At the top are the chromatophores, pigment sacs ringed by tiny muscles that expand and contract like drawstring curtains. Each one contains black, red, yellow, or brown pigments, and by stretching or shrinking them, the squid can control how much color appears on the skin. A small contraction reveals a pinpoint of dark. A full expansion creates a colored disc, and groups of these cells working in unison can generate vivid patterns in milliseconds. Beneath the chromatophores lie the iridophores, cells composed of stacked platelets that reflect light through constructive interference. These structures don't just mirror ambient light, they refract and polarize it, producing iridescent effects that shift with viewing angle. It's the same principle that makes oil slicks shimmer or peacock feathers glow. But the squid doesn't rely on coincidence. It controls these iridophores actively, tuning them to reflect particular wavelengths. Some species have been observed switching between red, green, and blue reflectance, depending on light conditions or social interactions. It's as if their skin speaks a language only some eyes can understand. Beneath that, deeper still, are leucophores, diffuse reflectors that scatter all light equally. They provide a neutral white base that enhances contrast for the layers above and allows the animal to brighten or dim its appearance depending on the environment. Think of it as the canvas, the iridophores as the digital glow, and the chromatophores as the pigments on top, working together to create dynamic, real-time body art that serves as both defense and offense. In squids like the longfin inshore squid, these systems are so refined that the animal can generate pulsing waves of color across its mantle during courtship or as a warning. But in predator-prey encounters, they serve a different role. Confusion. A school of squid under threat may erupt in synchronized bursts of strobe-like flickering, dazzling the eyes of predators like tuna or dolphins. These flashes are not random panic. They are controlled disorientations, flashes of light that overload motion detection and make it nearly impossible to target a single individual. What's even more astonishing is how this system is managed. The control is neural, fast, direct, and integrated with visual processing. Cephalopods don't use their eyes alone to see. There is growing evidence that their skin itself may be photosensitive. Embedded opsins, light-detecting proteins normally found in eyes, have been found in cephalopod skin, suggesting that their bodies can see light changes locally and respond without needing to consult the brain. This means a squid's flank can respond to shadow while the animal looks elsewhere. It's as though the skin has a low-resolution awareness of its environment, not conscious but reactive, not thought but perception in the flesh. In the deeper twilight zones of the ocean, where blue dominates and red vanishes entirely, these abilities take on new meaning. Down here, many predators use bioluminescence to lure or detect prey, and the rules of visibility change dramatically. To survive, some squid species, like the firefly squid, have taken camouflage in a new direction: counter-illumination. Along their undersides, they possess photophores, light-emitting organs that mimic the glow of the surface light above. This erases their silhouette when seen from below. It's not enough to be invisible. Down here, the key is to not cast a shadow. The photophores are tuned to match the intensity and wavelength of light at their depth, allowing the squid to literally glow the right amount to vanish. And this lighting is not just for defense. Some predators like the vampire squid and deep-sea bobtail squid use bursts of light not only to escape, but to startle, throwing off hunters with flashbangs of bioluminescence. In other species, flickers from specialized light organs are used to attract small prey, giving the illusion of movement in a current, or suggesting smaller organisms to bait the real target. Light, in these cases, becomes a weapon, just as vital as tentacles or teeth. All of these abilities, chromatophore expression, iridescence control, bioluminescence tuning, require vast computational effort and fine muscular control. Unlike fish, whose coloration is typically static or hormonally controlled, cephalopods make decisions in real time. Their skin is constantly adjusting to the backdrop, the angle of light, the perceived threat, and sometimes social signals. The color patterns they produce aren't just for hiding. They communicate warning, stress, readiness to mate, or signs of dominance. In cuttlefish, these signals can be so complex that males have been recorded showing two patterns at once: one to attract a female on one side of their body, while simultaneously showing a threat display to a rival on the other. It's camouflage and communication, split down the middle. Despite these marvels, their brilliance is short-lived. Like the octopus, most squid species live fast and die young. Some only survive a single year. They hatch from eggs already equipped with tiny chromatophores, flashing within days of birth. In that time, they must learn to hunt, hide, and manipulate their living skin with precision. It is a steep learning curve, but a necessary one. In a world where every shadow might be a threat, to pause is to perish, and to shine too brightly is to die. There is a strange poetry in the idea that such intelligent, graceful hunters live behind a curtain of light and illusion. They are not armored, they are not spiked or scaled. Their defense is to be misunderstood, to dazzle, deceive, and disappear. For cephalopods, invisibility is not absence. It's a dynamic performance. Their skin thinks, reacts, speaks, and misleads. And in the silent language of light and color, they remain some of the ocean's most sophisticated liars. The reef at midday is a scene of dazzling confusion. Color riots across every surface: fluorescent corals, waving anemones, darting fish that flash like jewels. Shafts of sunlight penetrate the clear water in long dancing columns, shifting with each wave above. It feels alive in every direction, humming with movement, noise, light, and pulse. And yet, within this overwhelming display, a silent theater of deception plays out just below the surface. At the foot of a stony coral ledge lies what appears to be a crusted lump of reef detritus, dull brown, rough-edged, unremarkable. Small gobies flit past it, a curious shrimp even perches briefly on its back, but nothing happens. The shape doesn't stir. And then, from the edge of that immobile shape, a lightning-fast flick, and a goby is gone, swallowed whole in a blink. The rock was never a rock. It was a predator in ambush, a stonefish, Sinancea verrucosa, arguably the most perfectly camouflaged hunter in the Indo-Pacific. Every fold of its skin, every wart-like protrusion, is tailored by evolution to mimic coral rubble. Even its texture is deceptive, encrusted with algae and soft polyps, often hosting live growths of reef flora. It doesn't pretend to be next to the coral. It is the coral until it opens its jaws and reveals what lies beneath. Stonefish are not agile hunters. They do not chase. They do not patrol. They wait, hours, sometimes entire days, buried beneath sand or posed against rock, barely drawing breath. Their attack is mechanical, a sudden vacuum created by rapidly opening jaws that sucks in prey in less than 0.015 seconds. To call it fast is an understatement. It is nearly unmeasurable. The prey, typically small fish or crustaceans, never sees it coming. One moment there's safety, the next only silence and settling silt. But the stonefish is only one player in a broader cast of masters in static disguise. Elsewhere on the reef, among delicate sponges and fluttering sea fans, hangs a fish so frail it seems made of paper. A leaf scorpionfish, Taenianatus triacanthus, sways gently with the water, mimicking the subtle rocking of marine vegetation. Its pectoral fins fan out like torn leaf margins, its dorsal spines broken in silhouette. Every movement is calculated to reinforce the illusion, not to deceive a predator, but to ambush its own prey. Like the stonefish, the leaf scorpionfish does not chase. It waits until small fish or shrimp venture too close, and then, with a swift gulp, they are gone. The disguise has done its job. Interestingly, these fish must remain still not just for their camouflage to succeed, but because motion, even slight, can give them away. Their metabolisms reflect this. Many of these ambush hunters operate at low energy thresholds. They rely on short, explosive bursts, not sustained effort. They eat infrequently, and when they do, it is calculated. The ocean does not reward waste. Camouflage on coral reefs isn't just about blending into color. It's about matching pattern, texture, shadow, and even the microflora of the substrate. Many fish enhance their disguise not through pigmentation alone, but by physically altering their appearance. Some are covered in filamentous appendages or algae-like growths that sway independently. The tasseled wobbegong, a type of carpet shark, grows elaborate dermal lobes around its mouth that resemble trailing seaweed. These lobes hide the shape of the head and conceal its motion sensors, giving it a near-invisible front edge until the moment it lunges. When it does strike, it doesn't bite down, it engulfs. The victim, often unaware it was even in danger, is simply no longer there. And then there's the paradox of defense. The disguise that keeps predators away also brings prey closer. In some parts of the Indo-Pacific, ambon scorpionfish have been found among rubble beds where juvenile fish congregate. To a passing juvenile, the scorpionfish looks like a patch of algae-covered rock. Safe, familiar, part of home. But the moment the juvenile strays too close, the ambush is triggered. What seemed like safety was danger in disguise, yet camouflage is not static across time. Many of these fish can change color, not with the instant precision of a cephalopod, but gradually, over days or weeks. They adjust to new surroundings by altering hormonal signals that regulate pigment cells, slowly growing to resemble their environment more closely. A scorpionfish relocated to a lighter section of reef will, over time, fade to a paler hue. One placed among darker coral will deepen in color. This adaptive ability means that even if the reef changes, the disguise can evolve alongside it. Perhaps most fascinating is that these disguises are not always perfect. Small inconsistencies, flaws in the mimicry are tolerated, because the ocean, with all its movement and complexity, allows room for imperfection. Predators aren't always watching carefully. Prey often make hasty decisions. The illusion only needs to be good enough to work. Not flawless, but functional. Evolution is not sculpting art, it is refining success. Some reef fish even go a step further. The frogfish, for instance, not only mimics coral or sponge, but lures prey with a built-in appendage resembling a worm or shrimp. This modified dorsal spine dangles over its mouth like a fishing rod, twitching just enough to catch the eye. In the chaos of reef life, a flash of motion draws attention. The prey approaches the lure and is consumed by the mouth hidden beneath it. The hunter didn't just hide. It staged a trap, used attention against its target. Yet for all their predatory success, these coral imposters are also fragile. Many rely entirely on the integrity of their habitat. Without the structure, color, and complexity of the reef, they are exposed, not just visually but physically. Their bodies are soft, their mobility limited, their defenses passive. They have no fallback. If the illusion fails, they die. The reef offers a stage that is constantly in flux. Coral grows, erodes, bleaches, recovers. In this environment of shifting boundaries, the creatures that survive are those that can disappear into it. Not through speed or strength, but through stillness, through illusion, through an evolutionary contract with the landscape that says, if I become part of you, I might live long enough to feed again. And so they wait, motionless, quiet, shaped by their silence, defined by their patience. In a world of flash and speed, these are the predators that don't chase. They simply convince the world they aren't there, until they are. In the chilled shallows of southern Australia, where cold currents sweep in from the Southern Ocean and the rocky seabed turns green with rising towers of kelp, a forest sways in slow motion. Sunlight pours through the water's surface in long, pale beams, broken into ribbons by the fronds of giant brown algae. The scene is both alien and oddly familiar, like walking through a rainforest suspended in water. But here the trunks bend and twist. The canopy flows instead of rustles, and the silence is pierced only by the muffled creak of shifting weed and the distant pop of invertebrate life at work. Amid this forest of shadow and movement, there is something else, a body that moves not with effort, but with the rhythm of the sea itself. It rocks gently with the kelp, its limbs trailing like fronds, its profile broken into a dozen appendages that look more like seaweed than anything alive. This is Phycodurus eques, the leafy sea dragon, a marvel of disguise so complete that even trained divers can overlook it entirely. Its body is a pale golden brown, speckled with muted green, with lobe-like extensions trailing from head to tail. These are not fins or weapons or tools. They are decorations, false leaves that serve no purpose but to deceive. They do not aid in propulsion. In fact, they hinder it, limiting the animal to slow, drifting movement. But in this forest, speed is not survival, resemblance is. Leafy sea dragons are not predators in the conventional sense. They do not ambush, they do not chase. They feed on tiny crustaceans, mysid shrimp, plankton, which they suck into their tubular snouts with quiet precision. Their success depends entirely on not being seen, not only by prey, but by the many dangers of their world. Crabs, larger fish, even diving birds can pose a threat. The sea dragon's safety lies in its commitment to the role. It becomes the kelp, in posture, in texture, in behavior, and it never breaks character. Nearby, clinging to a blade of weed with its tail coiled like a tendril, is another master of deception. A pipefish, long and slender, its body striped to match the vertical banding of the kelp. It doesn't swim through the forest. It leans with it, keeping its alignment parallel to the weed. When the fronds sway left, the pipefish leans. When the current shifts right, it follows. Its camouflage is not only visual, but behavioral. It mimics the rhythm of its world. What sets the pipefish apart is its subtlety. Unlike the sea dragon, which dazzles with elaborate ornamentation, the pipefish vanishes through simplicity. A straight line in a world of stems. Yet both species belong to the same peculiar family, the Syngnathidae, which also includes the seahorses. Their camouflage isn't just skin deep. These animals have evolved entire anatomies devoted to staying hidden. Their bodies are rigid, encased in bony rings rather than soft muscle. This limits their agility, but grants them stability in a swaying environment. Their mouths are fused into narrow tubes, allowing them to feed with minimal movement. Even their eyes move independently, scanning the world with quiet calculation, always alert, always waiting. As one ventures deeper into the kelp forest, the light dims and the stakes rise. This is a place of ambush. Where the leafy sea dragon survives by looking like drift, other hunters exploit the same shadows to lie in wait. The kelp greenling, a mottled predator of the temperate Pacific, hides among the root-like holdfasts at the base of the kelp columns. Its skin is blotched and speckled to match the shifting light that filters down through the canopy. It sits in the crevice of a rock, or buries slightly into the sediment, immobile, watching. When a smaller fish wanders too close, a short burst of speed brings the kill. This is not open ocean pursuit. This is forest hunting. Close quarters, quick decisions, short fuses. What defines camouflage here isn't color alone, it's context. The kelp forest is a dynamic environment. Light changes by the hour. Fronds rise and fall with the tide. Particles drift in the current, confusing outlines and softening edges. Many forest inhabitants have adapted to this by being not just camouflaged, but context-sensitive. The painted sculpin, for instance, can shift from speckled brown to mottled green depending on the substrate. Its skin hosts microflora, algae and bacteria, that further alter its appearance. Some individuals carry tufts of growth that sway independently, adding to the illusion. These fish don't blend into the forest. They collaborate with it. Above, closer to the surface, birds dive from the sky. Cormorants and shearwaters that plunge headfirst into the forest canopy, vanishing for seconds before surfacing with prey. These aerial predators force even the best camouflaged fish to remain vigilant. A single twitch, a shift in angle, and the illusion breaks. The difference between success and death is often the width of a shadow. Among the more unusual adaptations in this ecosystem is the use of transparency. Juvenile fish, not yet ready for full pattern camouflage, often rely on near invisibility instead. Some species of larval clingfish and wrasse remain almost entirely translucent, their internal organs faintly visible, their outlines almost undetectable unless backlit. As they mature and settle into adult habitats, they take on the color and markings suited to their chosen microhabitat, some matching kelp, others the reef below. Stillness is everything here, and silence. Not just physical silence, but behavioral restraint. Many species, like the giant kelpfish, are capable of freezing mid-swim when a shadow passes overhead. Others retreat slowly into crevices, never bolting or flinching. Panic is visible. Fear makes noise in a visual world. In the kelp forest, the best strategy is often to remain unnoticed, to never give a reason to be looked at twice. For researchers, observing these species requires patience. Even underwater, trained eyes can take minutes to distinguish a fish from its surroundings. And even then, many species aren't spotted until they move. When a juvenile sea dragon breaks formation with the weed, or when a pipefish changes its perch. It is a world where being almost invisible is often enough. And in a place this crowded, that margin is everything. In the grand narrative of ocean camouflage, the kelp forest offers a quieter, subtler chapter. Unlike the explosive flashes of squid or the sudden strikes of stonefish, this is camouflage as a way of life. It is slow, deliberate, continuous. These creatures do not vanish in a moment. They are always halfway there. Blurred edges, mismatched outlines, misread shapes. In a world ruled by motion, they survive by perfecting stillness. And so the forest sways, and with it, the shadows. Somewhere within, a predator waits, or simply pretends not to be. And in that pretending, in that motionless performance, it remains unseen. The surface of the polar sea appears motionless from above, a vast frozen expanse of broken floes and wind-burnished ridges. But beneath this brittle ceiling, a very different world unfolds. Here, in the coldest corners of Earth's oceans, where water temperatures plunge below the freezing point of fresh water and daylight can vanish for months, survival is shaped not by the colors of the reef or the textures of kelp, but by light, or the absence of it. In this monochrome world of whites and shadowed blues, camouflage takes on a colder, more austere form. The art of vanishing in a place where color barely exists. The ice canopy above filters light in strange ways. Sunlight, when it reaches these waters at all, is diffused into soft, wavering shafts, scattered by layers of snow and air trapped in the ice. Cracks and melt holes produce beams of clarity, narrow tunnels of brilliance that penetrate downward like underwater spotlights. Everything else remains cloaked in a pale, drifting twilight, interrupted only by glimmers of plankton and the occasional passing shadow. It is within this uneven illumination that the polar camouflage specialists thrive. One of the most extraordinary is the icefish, belonging to the family Channicthidae. Found along the continental shelves of Antarctica, these fish glide slowly beneath the ice, their bodies pale and ghost-like, almost translucent. At first glance, they seem incomplete, like unfinished sketches drifting through the water. And in many ways, they are. Icefish are unique among vertebrates in that their blood carries no hemoglobin. Their blood is clear, their flesh largely devoid of pigment. This biological oddity evolved not as a form of camouflage alone, but as a necessity in oxygen-rich freezing waters where metabolic demands can be met without red blood cells. Yet the result is a fish that, quite literally, fades into the water column. Their bones, too, are less dense than in other fish, making their bodies neutrally buoyant, ideal for drifting just beneath the ice, barely moving, barely visible. They do not use speed to escape or ambush to strike. Instead, they rely on stillness and pallor, allowing light to pass through them as much as it reflects away. In the polar seas, where shadows kill and brightness blinds, invisibility often comes not from matching the background, but from being less present altogether. Among the invertebrates of these frozen waters, similar strategies abound. Hovering beneath the ice are gelatinous drifters, Arctic jellyfish, comb jellies, and salps that are as fragile as they are undetectable. Many of these creatures are almost entirely transparent, their bodies refracting light so cleanly that only a trace of shadow or ripple reveals their presence. Some, like the Cyanea capillata, the lion's mane jellyfish, grow to extraordinary sizes, but remain eerily elusive due to their ghost-like translucence and trailing, near-invisible tentacles that can extend over 30 meters. They drift through the water column like pale storms, occasionally pulsing with a soft rhythm, each beat barely disrupting the silence of the sea. Further down, as light fades into the indigo of deeper polar waters, transparency alone is no longer enough. Here, many species adopt counter-illumination, a sophisticated tactic where organisms produce light from their own bodies, not to stand out, but to blend in. It is especially effective in these dim waters, where predators scan upward for silhouettes against the faint glow of the surface. Tiny fish like myctophids, lanternfish, are equipped with rows of photophores along their undersides. These organs emit a controlled light that matches the ambient glow from above, erasing the shadow the body would otherwise cast. The fish becomes a ghost light, visible to the eye but not to the instinct. But not all polar predators choose invisibility through stillness or transparency. Some exploit the ice itself. Seals, particularly the leopard seal of Antarctica, patrol the undersides of sea ice in search of prey. Penguins, fish, even other seals. Their camouflage is dynamic, utilizing both coloration and movement. Their backs are dark, almost black, blending into the deep water when viewed from above. Their bellies are pale, nearly white, merging with the light that filters from the ice above. This classic countershading, dark on top, light below, is a widespread adaptation in open water animals. But in the polar seas, it becomes especially effective due to the binary contrast of the environment, light above, darkness below. Leopard seals use more than coloration, they use ice shadows as hunting grounds. As penguins dive through melt holes and narrow leads between flows, the leopard seal waits in silence just beyond the light, concealed within the long, soft shadows that stretch beneath the jagged under-ice. The moment prey enters these shadows, the ambush begins. It is a hunt orchestrated not in open pursuit, but through environmental geometry, hiding not from light, but within the space it doesn't reach. Some polar predators wield bioluminescence not only for concealment, but for manipulation. In the depths of the Arctic, where sunlight never reaches, certain predatory species such as the dragonfish and black sea devil use hanging lures, tiny glowing beacons of blue or green, to attract prey toward their nearly invisible bodies. In these waters, visibility is a liability, so these hunters have minimized it almost completely. Their bodies absorb more light than they reflect, with pigments that render them effectively matte black in every direction. The lure becomes the only visible thing, a beacon in the abyss, until jaws strike from the darkness. The contrast between glowing lure and unseen attacker is one of nature's most chilling adaptations, especially in an ecosystem where bioluminescence is sometimes the only visible light. Despite the cold, life here is rich, adapted not to resist the cold but to exist because of it. Enzymes in polar fish have evolved to function in sub-zero temperatures, and antifreeze proteins circulate in their blood, preventing ice crystals from forming in their tissues. These physiological adaptations underpin their stealth. Movement is slow not by choice, but by necessity. Energetics in polar waters are measured, deliberate, restrained. The animals that survive here do so through efficiency, and invisibility becomes part of that balance, minimizing exposure, maximizing opportunity. For the human eye, the illusion is nearly total. Divers report entire schools of transparent fish swimming past, visible only when disturbed. Cameras pick up flickers of movement where nothing seems to exist. In the world beneath the polar ice, the line between presence and absence is thin, often imperceptible. To see the hunter, you must look for what isn't moving, for a break in the flow, for the shape that's a little too smooth, for the silence that masks intent. Here, in a realm where motion betrays and color is useless, predators have learned to wear the ice, not as armor, but as absence. They do not stand out. They subtract themselves from the scene. And in doing so, they become the most successful hunters of all, the ones that never have to be seen to strike. As the sun slips below the horizon, the ocean does not fall silent. It transforms. The vibrant palette of the reef fades into grays and blues, and the flickering chaos of the day is replaced by a subdued rhythm of darkness and drift. Above, the moon casts a silvery glow across the surface, creating a dim halo of light that penetrates the shallows, but fails to illuminate the depths below. In this muted underwater world, camouflage is no longer a matter of blending into colors or patterns. Instead, it becomes a matter of light itself, of controlling, countering, and manipulating it in ways that defy instinct and physics. Out on the sand flats under this pale twilight, the bobtail squid begins to stir. During the day, it remains hidden beneath the seafloor, buried in fine sediment with only its eyes visible, two dark marbles scanning for danger. Its skin takes on the color and texture of the sand around it, a simple but effective defense. But as darkness deepens and the current slackens, it emerges. No longer just a passive observer, it becomes an active predator, small, rotund, and oddly graceful as it hovers just inches above the bottom. Its arms curl beneath its body, and its body pulses with a faint, almost imperceptible light. That glow is not an accident, it is strategy. The bobtail squid is equipped with a unique bioluminescent organ in its mantle, home to symbiotic bacteria, Vibrio fischeri, that emit light. But this light is not random or decorative. It serves a precise function: counter-illumination. In a world where most predators look upward to silhouette their prey against the moonlit surface, casting a shadow is fatal. The bobtail squid's glowing underside neutralizes that shadow, making its outline disappear when seen from below. By adjusting the intensity of the glow to match the brightness of the ambient moonlight, the squid renders itself nearly invisible to any watchful eye, fish, shrimp, or octopus lurking beneath. The squid doesn't fight light, it becomes it. This tactic isn't unique to bobtail squid. In deeper pelagic waters, where darkness reigns and only the faintest light from the stars and moon filters down, many organisms employ this same strategy. Lanternfish, hatchetfish, and midwater squids all use arrays of photophores to match the downwelling light. Their bodies are shaped to minimize shadows, and their light organs are arranged with mathematical precision to eliminate contrast. Some can even control which sections of their bodies glow, using muscular shutters to fine-tune the shape of their glow field, depending on their angle to potential threats. But unlike in the deep ocean, in the shallows, camouflage at night is twofold. There is not only the problem of predators below, but the complexity of shadows cast across the seabed. Here, the rules of concealment are rewritten with every ripple, every flash of cloud cover above. And that is where the bobtail squid excels. It not only erases its shadow, but adjusts its position and brightness to remain a ghost among moonlit sand patterns. Its body is soft, capable of slight deformation to mimic the contours of the seafloor. It pulses, stops, pulses again, like a heartbeat in the dark, in sync with the sea's breath. Predators aren't the only ones fooled. Prey, too, are susceptible to these illusions. Tiny crustaceans, amphipods, mysids, skim the seabed in near blindness, relying on contrast to sense danger. When the squid strikes, it does so without a warning flicker. A short lunge, a flash of suction, and the prey vanishes into arms that glow no brighter than the sand they hover above. It is a kill born of silence and lighting precision, not speed alone. Elsewhere in the nighttime reef, similar dramas unfold. Crustaceans like decorator crabs, previously dormant by daylight, emerge wrapped in their hand-picked armor, bits of algae, sponge, and debris painstakingly arranged over their shells. Unlike daytime camouflage, theirs must account for lunar light scatter, and many adapt by choosing materials that reflect light at the same angle and intensity as the terrain around them. Some species, like the sponge crab, even cut pieces of live sponge to carry atop their backs, maintaining a disguise that grows and changes with them. The flashlight fish, named for the bright photophores beneath its eyes, adds another layer of complexity to the nocturnal game. These photophores are not always on. In fact, the fish can cover them with darkened tissue flaps like eyelids, using bursts of light to navigate, to confuse predators, or to coordinate with others. But they also serve a subtler purpose: temporary distraction. When threatened, flashlight fish have been observed pulsing their lights rapidly while darting erratically, creating a strobe-like effect that disorients predators. The eye focuses on the light, not the fish. And when the light vanishes, so does the target. Even invertebrates that seem unremarkable by day take on new roles in the nocturnal theater. Certain species of mantis shrimp, for example, become ambush hunters after dusk, relying on polarized light and shadowed movement to locate prey. Their compound eyes, already among the most complex in the animal kingdom, allow them to see wavelengths of light invisible to human eyes, including circularly polarized light. This grants them the ability to detect prey hiding beneath layers of algae or sediment, creatures that, by human standards, would be perfectly concealed. And then there are the passive drifters, jellyfish and comb jellies. that rise toward the surface after dark in one of the largest daily migrations on Earth. Many of these species use shimmering rows of cilia, not for defense, but as a consequence of movement. Their camouflage comes from their transparency, not glow. But even these seemingly helpless organisms have evolved subtle optical tricks. Some refract light in a way that renders their edges nearly invisible, while others scatter light through internal structures to minimize detection. Some are so effectively concealed that even their predators, like small fish and sea turtles, must rely on touch rather than sight to detect them. What binds all these nocturnal strategies together is not brightness or darkness, but precision in contrast. Under the moon, under the stars, in the half-light of clouded nights, predators and prey are not measured by how fast they move or how strong they are, but by how well they manage light. Whether they emit it, scatter it, match it, or erase it, the night is governed by an invisible choreography of photons and patience. In this world, invisibility is not a static achievement. It is a dynamic process, constantly recalibrated with every cloud that drifts across the moon, every surge of tide, every flash of bioluminescent algae stirred by a tail fin. For the hunters of the night sea, to remain unseen is not just to hide, it is to understand light better than those who chase or flee it. And so the ocean breathes under the moon, alive with creatures that see without eyes, that shine to disappear, that hunt by shadow and feed on miscalculation. In their silence and precision, they've turned the night into an ecosystem of deception, where being seen is optional, but being missed is survival. In the shallow coastal zones where the coral gardens end and the water turns clouded with suspended particles, there lies an ecosystem built not of color and spectacle, but of grit and patience. The seabed here is soft, a silty expanse of fine sand, crushed shells, and decaying organic matter. The water is often turbid, visibility poor, with the sun reaching down in filtered beams that shimmer but rarely illuminate. Nothing here screams life at first glance. It looks dead, or at least uneventful. But that's precisely the point. This is a world where stillness isn't emptiness, it's a trap. In this muted battlefield, camouflage doesn't flash or shimmer. It settles. Slowly, methodically, and with surgical precision, predators insert themselves into the floor itself. Their bodies vanish beneath thin layers of sand or mud until the boundary between flesh and seabed disappears. A single twitch of a fin smooths over the disturbance, and then nothing. Only a pair of upward-facing eyes, glinting faintly, gives any hint that something alive waits just beneath. The stargazer, a fish with a name that contradicts its habitat, is one of the masters of this technique. Buried with its eyes and mouth pointed vertically, it spends much of its life in ambush. Unlike typical predators, it does not pursue. It lies in complete stillness, watching. Its mouth, fringed with sensory filaments, opens directly upward, a design tailor-made for explosive vertical attack. The slightest vibration in the water, the pulse of a swimming fish, the scrape of a crab's leg, triggers the launch. From beneath the sand, the stargazer bursts forth, jaws agape, creating a vacuum that sucks the prey in before it can even comprehend the danger. The violence of the strike is hidden behind silence. Only the disturbed cloud of sediment remains in its wake. The stargazer's disguise is enhanced by more than just burial. Its body is mottled with sand-colored blotches and textures, and its eyes are adapted to see through the silt. Even its respiration is covert. Tubes extend from its gills to the surface of the sediment, allowing it to breathe without movement, without revealing the telltale pulse of gill flaps. Some species even possess electric organs, capable of delivering mild shocks to stun prey or deter attackers. A rare and bizarre twist in the camouflage playbook. Here, invisibility isn't passive, it's electrified. Elsewhere along the flats, flatfish, including flounders, soles, and halibut, conduct a subtler but equally effective performance. These fish are born symmetrical, with eyes on both sides of the head like typical swimmers. But as they mature, one eye migrates across the skull to join the other, and the body flattens, adapting to a life pressed against the bottom. Their entire existence becomes horizontal, not only in shape but in strategy. They settle into the sand, skin to seabed, eyes scanning upward. What makes the flatfish remarkable is its ability to change its coloration and texture in real time to match the substrate. Specialized cells, chromatophores, expand and contract to mimic the exact shade and grain of the surrounding sand. This isn't mere blending. Its active mimicry of the smallest visual details. Some species can even imitate scattered shell fragments or algae strands. Even the pattern of sunlight ripples dancing across the seabed is approximated. This disguise is so effective that predators swim past at close range, unaware, while the flatfish remains motionless, heart barely beating, trusting that its own absence will save it. When flatfish do strike, it is sudden and efficient. A crab crawling too close may find itself snatched in a sideways lunge that seems anatomically impossible. The fish, inert one moment, flexes into action the next, jaws extending, fins folding into a powerful surge. The sediment erupts around it, obscuring the scene and giving the predator precious seconds to subdue its catch. Then, as quickly as it moved, it vanishes again beneath the settling sand. But not all ambush artists are so large. In this same environment, lizardfish and goby species use their own variations on static hunting. Lizardfish often rest on the seabed with bodies exposed but perfectly colored to match. Their flattened heads and recessed eyes allow them to stay streamlined with the sand. Gobies, especially sand-dwelling varieties, dig small pits or co-opt burrows from which they launch brief ambushes on passing prey. They cooperate with shrimp in some regions, forming mutualistic partnerships where the shrimp digs and maintains the burrow while the goby stands watch. It's a security system in an ecosystem built on betrayal. What defines ambush camouflage in these soft-bottom habitats is its integration with physics. The water here is rarely still. Tides shift, waves break, and bottom currents sweep loose sediment in constant motion. These movements obscure outlines, disorient predators, and provide cover, but they also threaten to uncover. The challenge for these camouflaged predators is not just to remain hidden, but to remain hidden through change, to adapt in place, to readjust, rebury, reblend, without attracting attention. Even predators at the top of the food chain know to use the muck. Cuttlefish, among the most versatile cephalopods, occasionally hunt in these regions, not through rapid-fire camouflage, but through deceptive slowness. A cuttlefish can lower itself to the bottom, flattening its mantle, and shift its color to match the sand. From this position, it can extend feeding tentacles forward like drawn-out spears, striking only when prey is within a precise range. Sometimes, it will disguise itself as a harmless part of the seafloor, adopting the posture of a small mound or debris. The mimicry isn't about a perfect likeness. It's about plausibility in a landscape of clutter. This muddy world, for all its subdued palette, is a stage of tension. Each grain of sand can hide a predator. Each motionless patch may contain eyes. The silence is not peace, it is calculation. These hunters do not seek the chase. They prefer the odds of patience, the edge of surprise, the benefit of vanishing until the moment of truth. They let the prey come to them, guided by routine and hunger, unaware that the floor itself has teeth. And so the flats remain still, not empty, but occupied by absence. The ambushers beneath know that every vibration could mean opportunity. And when that vibration gets too close, the silence will break, in an explosion of silt and a flash of muscle, and then settle again, as if nothing happened at all. The coral reef is often compared to a city, alive with movement, teeming with residents and brimming with noise, even if that noise is mostly clicks, snaps, and the churn of water. But unlike a city, here the faces are rarely what they seem. Deception, not strength or speed, is the reigning currency. Within these tangled corridors of branching coral and anemone gardens, some of the most astonishing hunters and escape artists wear masks more convincing than nature should allow. These are the masters of mimicry, animals that do not simply hide from their predators or prey, but assume entirely different identities. In this realm of light and complexity, being unremarkable isn't enough. To survive here, many creatures must be something else entirely. Near the muck-draped seafloor of an Indonesian reef, a small boneless body pulses across the sand, changing shape as fluidly as spilled ink. This is the mimic octopus, a master impressionist with a repertoire as large as its territory is small. As it glides, it flares two arms outward in rigid spikes, trailing its body behind. And for a moment, it becomes a venomous lionfish, complete with fin ray mimicry. Seconds later, it flattens itself against the seafloor and hides 6 arms in a burrow, leaving only 2 visible, banded black and white. The posture, the motion, the striping all combine into a chilling likeness of a sea snake, one of the reef's most feared predators. Later still, it folds into the rough outline of a crab, scuttling sideways with stiff-jointed realism. No animal taught it these acts. It observed. It adapted. And it evolved not to escape unseen, but to be seen as something else entirely. What makes this so remarkable is not simply the range of impersonations, but the context in which they're chosen. The mimic octopus doesn't cycle through disguises at random. It selects the right mimic based on the threat it perceives. When harassed by damselfish, it mimics their predators. When navigating open sand, it imitates flatfish. This is deception not as an instinct but as a behavioral strategy, a calculated performance enacted on a stage where the wrong role can mean death. Mimicry in the reef isn't exclusive to octopuses. Across the Indo-Pacific, another imposter thrives by twisting trust into a weapon. The false cleanerfish is nearly indistinguishable from the blue-streaked cleanorasser, a vital reef inhabitant known for plucking parasites and dead skin from the bodies of larger fish. These cleanorasses are so trusted that even moray eels and groupers allow them into their gills and mouths, offering up sensitive areas in exchange for cleaning. But the false cleanerfish abuses that trust. It copies the wrass's colors, posture, and even the darting, flickering motion of its swimming style. At a glance, it is the same fish. But when the imposter approaches a host, it doesn't clean, it bites, tearing off a chunk of skin or fin and darting away before the host realizes the con. These aggressive mimics can live side by side with their legitimate counterparts, the truth hidden only until the wound is felt. The implications of this mimicry ripple through the ecosystem. Some fish learn to become more cautious of all cleanorasses, casting suspicion on a species that is otherwise beneficial. The balance of trust, an invisible thread tying together multiple species, is weakened, all because of one copycat that trades honesty for opportunity. Elsewhere on the underside of ledges and within reef crevices, scorpionfish and frogfish demonstrate another type of deception, aggressive mimicry that uses imitation not for defense but to lure prey. The frogfish, an oddball of the anglerfish family, is particularly well armed for this ruse. Its body is bulbous, wart-covered, and colored to match surrounding sponges or coral, while a modified dorsal spine ends in a fleshy lure, a baitfish mimic that it twitches rhythmically in front of its mouth. Tiny fish, drawn to what seems like an easy meal, approach the lure and are swallowed whole in a strike that occurs in less than a tenth of a second. There is no chase. The predator becomes part of the scenery, and the prey delivers itself. The effectiveness of this deception hinges on subtlety. A lure that moves too unnaturally might raise alarm. A skin tone just slightly off could betray the predator's presence. But evolution here fine-tunes every edge. Some frogfish even mimic the exact color gradation and texture of sponge species common in their area. The illusion is comprehensive and fatal. Not all disguises in the reef rely on visual mimicry alone. Some depend on chemical camouflage. The harlequin filefish, for instance, can alter not only its coloration to match the surrounding coral, but also its chemical signature, allowing it to go unnoticed by coral-feeding predators like damselfish. This adaptation lets it linger among coral polyps without triggering defensive attacks, effectively blending in at a molecular level. In a world where scent and taste are just as important as sight, this biochemical mimicry is a crucial and rarely observed layer of survival. In the chaotic cloud of a spawning event, when hundreds of reef species release gametes in synchronized bursts, other forms of mimicry emerge. Some small fish mimic juveniles of larger species, disguising themselves in the frenzy. This grants them access to feeding zones or protection from aggression. The illusion only needs to hold for moments, long enough to eat, to escape, or to breed. What unites all these strategies is not just the ability to blend in, but the ability to be believed. The mimic's success depends on the viewer's recognition, or misrecognition, of familiar shapes, motions, or behaviors. These disguises exploit the shortcuts evolution has built into perception. A banded pattern means danger, a twitching fin means food, a particular posture means safety. And in that exploitation, these animals turn instinct into vulnerability. In the coral reef, where every crevice holds both predator and prey, and where attention spans are short, to mimic is to manipulate. The reef's best imposters don't vanish, they misdirect. They survive not by absence, but by presence that confuses, disarms, or deceives among coral branches and sponges, beneath ledges and drifting over sand patches. The greatest threat may not be what hides, but what appears to be familiar. Because in this environment of overlapping senses and compressed space, the most dangerous creature is not always the fastest, the largest, or the most toxic. It is the one that tells the most convincing lie. And in the reef's complex theater of life and death, that lie, delivered through color, posture, motion, or mimicry, is often believed until it's too late.
Far from the coral reefs and shadowy seabeds, beyond the swaying forests of kelp and the shelter of coastal flats, lies the open ocean, a vast, borderless wilderness of blue that stretches in every direction.
Here, the rules of concealment are rewritten. There are no rocks to hide behind, no seabed to bury into, no coral shapes to mimic. The pelagic zone is a world defined by exposure. Movement is constant, visibility is long range, and the stakes are brutally high. In this arena of endurance and speed, the only place left to hide is inside the blur. At first glance, camouflage might seem pointless in open water. After all, there's nowhere to crouch, no background to match. But nature, as always, adapts not by what seems obvious, but by what works. In this blue desert, certain predators have evolved a way to disappear not by becoming static, but by embracing motion itself as camouflage. They flicker, shimmer, elongate, pulse, and refract. They do not vanish by stopping. They vanish by moving faster than the eye can interpret. Among the most captivating of these is the pelagic squid, especially species like Stenoteuthis ualaniensis, the purple-back flying squid. Sleek, streamlined, and built for velocity, these animals cruise the epipelagic zone in coordinated shoals, using propulsion as both locomotion and defense. They move by jetting, sucking water into a muscular mantle and forcefully ejecting it to thrust themselves forward. But their movement alone isn't what makes them vanish. It's their skin, a dynamic reflective surface coated in microscopic mirrors called iridophores. These iridophores are layers of cells that manipulate light through structural interference. As the squid moves, its skin doesn't merely reflect. It refracts and redirects wavelengths at shifting angles, producing quicksilver flashes that pulse like strobes. To a viewer below or beside, the squid becomes not an object but a series of glints, like sunlight dancing on wavelets. This optical confusion masks their outline. To a predator or prey, they don't look like animals. They resemble a scattering of light, devoid of structure or intent. In coordinated groups, this effect is amplified. Dozens of squid pulse in synchronized arcs, each one shedding identity, becoming part of a streaking storm of brilliance. Even their chromatophores, pigment cells capable of rapid expansion, are incorporated into this performance. As they dart, chromatophores flare in split-second bursts, producing contrast patterns that further confuse perception. A squid may flash a stripe mid-turn, creating the illusion of a bend or a sudden stall, only to resume speed in another direction. These are not colors meant to match a background. They are meant to deceive the mechanics of motion detection, to create false trajectories, distract the pursuit reflex, and conceal acceleration in a chaos of shifting brightness. Another master of this motion-borne deception is the ribbonfish, particularly the deep-bodied Trachypterus species, which glide through mid-water with an almost spectral elegance. Their bodies are laterally compressed and metallic, with long trailing dorsal fins that undulate like silk. Seen in motion, they resemble loose ribbons caught in a current rather than structured predators. The illusion is strengthened by their smooth, mirror-like skin, which reflects the surrounding water with just enough distortion to break up their shape. Ribbonfish don't shimmer with intensity. They shimmer with softness, blurring edges, altering scale, and erasing clear borders. This strategy works in part because of how vision functions underwater. Predators often rely on contrast and edge detection to locate targets. But a creature that oscillates between visible and invisible in milliseconds, one that appears longer than it is in one frame and disappears in the next, becomes nearly impossible to lock onto. The brain expects continuity, a line, a path, a shape. But these predators break that continuity. They weaponize visual noise. Interestingly, these illusions are not just defensive. Many motion-based camouflagers are active hunters, using their optical tricks not to escape, but to close in. A squid approaching prey will sometimes strobe its chromatophores in a wave, creating a distraction that mimics multiple approaches. The prey, momentarily overwhelmed, hesitates, and in that hesitation, the squid strikes. Some researchers believe this technique, sometimes described as dynamic dazzle,
may serve a similar function to the motion dazzle used by fast-moving zebras and other land animals, blurring the predator's perception of speed and trajectory. Only here, it's happening in 3 dimensions, at depth, in light that refracts and distorts. The phenomenon is even more extreme in species like the glass squid, which combines transparency, iridescence, and motion to become nearly imperceptible. While not fast movers by pelagic standards, glass squids float with an eerie neutrality, their bodies refracting background light in all directions. When startled, they rotate rapidly while pulsing chromatophores and emitting flashes of bioluminescence from their mantle. The result is disorientation, not just for the predator, but arguably for the observer too. The creature becomes a moving question mark, part reflection, part transparency, part illusion. When it flees, its departure is not a shape vanishing into the blue, but the dissipation of light itself. Some open water predators have evolved to weaponize shape distortion as well. The snipe eel, with its whip-thin body and elongated jaws, swims with sinuous undulations that make its body seem twice as long, or alternatively, impossible to measure. From below, its silhouette shifts too rapidly to determine size or speed. It is not armored. It is not quick in the traditional sense, but it is difficult to grasp, visually and physically. By the time a predator adjusts its aim, the eel has already curved away. Perhaps the most subtle part of motion-based camouflage is that it does not require the creature to be permanently active. It relies on the illusion of timed invisibility, moving just long enough at just the right angle through just the right light to trick the eye into losing it. Then a pause, a reset, a chance to strike again. In the open sea, where everything is constantly moving, plankton drifting, light rippling, currents swaying, motion is not suspicion. It is background. These predators disappear by becoming part of that backdrop, not in color but in kinetics. In a world with no walls, no floor and no ceiling, they have found ways to slip between frames of reference. They do not vanish behind cover, they vanish inside vision itself. And as they streak through the water in bursts of silver, pulse and blur, they are not only hiding, they are hunting with the mask of motion, cloaked not in stillness but in velocity that cannot be followed. In the vast, layered theaters of the ocean, from sunlit shallows to pitch-black trenches, one rule reigns supreme. To be seen is to be at risk. Whether predator or prey, the moment a silhouette, a shadow, a ripple in the wrong direction is perceived, the balance can shift, from stalker to pursued, from unnoticed to exposed. In this world sculpted by pressure, light, and constant movement, invisibility is not a superpower. It is a biological necessity, an outcome of millennia of arms races fought not with fangs or speed alone, but with the subtle mastery of misdirection. Camouflage in the ocean is not a singular trick passed down from one clever ancestor. It is a convergent solution that has emerged again and again, shaped by distinct environments and needs. In shallow reefs, camouflage takes the form of mimicry. The octopus that imitates venomous sea snakes, or the scorpionfish that becomes indistinguishable from coral rubble. These are habitats crowded with shapes and color, where deception thrives on detail. Texture, pattern, posture, everything becomes part of the disguise. Evolution here is granular. A fish survives not by being invisible in the abstract, but by being invisible in a specific context. The algae tuft beside it, the sponge wall behind, the sand it rests upon. Just meters away in the exposed sandy flats, a different kind of invisibility has evolved. Here, where the terrain is flat and unforgiving, predators and prey have learned to disappear into the environment. Flounders reshape themselves to hug the contours of the seabed, altering their pigmentation to match the exact hue of the sediment grain. Stargazers bury themselves entirely, turning only their eyes and mouths skyward. These aren't disguises that pretend to be something else. These are adaptations that erase form altogether. Invisibility here means becoming a texture, indistinguishable from the terrain beneath. As we move outward, beyond the reef's reach and into the mid-water column, camouflage must contend with a new challenge: the absence of any background at all. There is nothing to match, no coral to hide among, no shadows to merge with. Here, organisms like pelagic squid and ribbonfish must craft deception from light and speed itself. Their bodies shimmer and flicker, reflecting light in fragmented pulses, so that what passes through the water is not a creature, but a scattered blur of motion. To observers below or behind, the outline is lost, the shape corrupted by glare and movement. It is camouflage forged from momentum, not a disappearance in stillness but in change.
Descending deeper still into the twilight and midnight zones, where sunlight fades and pressure mounts, the arms race evolves again. Down here, organisms face a binary choice: produce light or absorb it. Many choose the former, wielding bioluminescence not to be seen, but to confuse, distract, or erase. Lanternfish and hatchetfish use counter-illumination to cancel their own shadows when seen from below. Their undersides glow just enough to match the faint light above, masking them in a perfect mimicry of absence. Others, like the anglerfish, attract prey to their mouths with glowing lures, allowing them to stay motionless and hidden in the abyss. Still others, like deep-sea jellyfish and comb jellies, use transparency and refraction to vanish almost completely, rendering themselves as drifting voids, felt more than seen. And yet, the most telling expression of camouflage's power may not lie in how it functions individually, but in how it has shaped interactions across entire ecosystems. Reef fish patrol cleaning stations where imposters lurk among the helpful. Crustaceans decorate themselves in living sponge and algae to be ignored by both predator and prey. Prey fish mimic poisonous species, leveraging another's reputation for their own safety. Predators mimic prey to get close without triggering alarm. There are no moral lines here, only successful strategies. Even the youngest of species enter the game early. Juvenile fish are often born near transparent, an initial defense against visual predators. As they grow, their camouflage evolves with them, tailored to their shifting habitats. Some lose this transparency in favor of patterning. Others develop false eye spots or disruptive stripes. Evolution does not reward permanence in appearance. It rewards plausibility in the moment. The ocean doesn't care what you look like, as long as it works. It's worth noting that this arms race is not waged in one direction. Predators, too, are learning. Vision in marine animals has diversified to counter camouflage. Many reef fish have UV-sensitive eyes, allowing them to detect markings invisible to human observers. Dolphins use echolocation to reveal the shape beneath the blur. Some predators have learned to exploit motion, flushing prey from hiding with sudden bursts of speed or light. As deception grows more intricate, so too does detection, and the evolutionary pressure spins ever onward. There's a quiet irony in all this. For creatures that depend so much on not being seen, much of their beauty is revealed only when the illusion fails. When a frogfish strikes, when an octopus flees in a burst of color, when a bobtail squid flashes as it rises from the sand. These moments, brief and violent or cautious and calculated, offer glimpses into the hidden brilliance of marine life's survival playbook. But they are exceptions. Most of the time, the masters of invisibility remain just that, unseen. In the end, what camouflage reveals is not just the creativity of evolution, but the intensity of vulnerability in the sea. Every creature is both predator and prey. Every movement is a risk. The best defense is not teeth, nor armor, nor speed. It is absence, an ability to subtract oneself from the story until the moment of necessity. Invisibility in the ocean is not about disappearance. It is about control. Control over light, shadow, texture, attention. A constant negotiation between exposure and secrecy. And as we surface, rising out of this world of hidden battles and unseen brilliance, we leave behind not silence, but a choreography of creatures that have learned not simply to live, but to disappear better than we ever knew was possible.